Hello everyone. Now we have to discuss the analysis, that is measurements of power. Measurement of power in balanced three-phase load. Here I am going to consider the load as lagging load. That is, a three-phase balanced voltage is applied on a balanced three-phase load when the current, that is phase current, lags phase voltage by some angle. Okay. Due to lagging load, we can write that point. A three-phase balanced voltage is applied on a balanced three-phase load when phase current lags phase voltage by 5. With respect to lagging angle, we can do the analysis. Okay. Before that, I would like to introduce a wattmeter. Sorry, not these many coils, only singleton, like this. Okay. Like this. This is wattmeter. Okay. This is current coil. This is voltage coil or potential coil. Okay. Wattmeter. CC means what? Current coil. This is what? Potential coil. Where we have to connect this current coil? Connect in series with phases. Like that. What about potential coil, which is connect across two phases? That's it. Voltage across, we have voltage in series with current. Clear? This is basic concept of wattmeter. We have 4 terminals MLCV for this wattmeter that you have to get from the concept of measurements. Okay. Now here I am providing the connection diagram, 2 wattmeter connection diagram. Okay. Two wattmeter connection diagram. We need only 2 wattmeters to measure three-phase power. How could we measure that power? By using this 2 wattmeter. We are going to discuss now. Okay. 2 wattmeter connection diagram. That is, consider this is the load. Okay. From this load we are having what? Let us take like this. Okay, from here, that's it. Okay, now we are providing the wattmeter. Okay, like this. Okay, this is wattmeter 1, this is wattmeter 2. Clear? This is what R phase, this is, let us say this is B, right? This is R, Y, B, this is Y. Okay, the current through this R phase is nothing but IR, like that. This is IB, this is IY. Clear? And this is what CC, this is PC. That's it. Clear? And this is what VR, phase voltage. This is VY, this is VB. So phase voltage is completed. And finally VR, B, VB. Okay, no need. Already you know that, right? Between two lines we have line voltage. Then we know that, see, we are connecting the wattmeter 1 in R phase, like that we are connecting the wattmeter 2 in B phase. So the current coil is connected in series with R phase as well as B phase. Okay, like that the potential coil of wattmeter 1 is connected in parallel with R phase and Y phase, like that the potential coil in wattmeter 2 is connected in parallel with B and Y. So we need 2 wattmeters to measure 3-phase power. Okay, so you are considering only 2 phases. We are connecting the another terminal of potential coil to last phase, that is third phase. Okay, from this we can write current through current coil of wattmeter 1 and wattmeter 2, right? We have 2 wattmeters. Therefore current through current coil of wattmeter 1, which is equals to what? Like that for wattmeter 2 is what? Which is the current through current coil in this case is what? IR, in this case IB. IR, in this case we have IB, right? Like that, listen carefully, the potential difference across voltage coil across voltage coil of, or you can write of, here also between the potential difference across voltage coil of wattmeter 1 and wattmeter 2. See, wattmeter PC is connected between R and Y, first case, that is for first wattmeter. Like that for second wattmeter it is present between B and Y, right? That is for this voltage, right, between R and Y. That's why line voltage VRY, which is equals to VR minus VY for this wattmeter between what? B and Y. So that's why VBY, which is equals to what? VB minus VY. That's it. Okay. This is about voltages. Completed. We have current coil currents and potential coil voltages. Now we have to draw the phasor diagrams with respect to this. So we all know that load is what? Lagging load, and the system is star connected system, right? What is our procedure? First we have to draw phase voltage. This is Vy. This is what? Vb. Completed. See the load. Load is what? Considering lagging load. Therefore, IR should be lags Vr by some angle. Okay, this is IR. This is Iy. This is Ib. Completed. Next, we have to get Vry. Vr minus Vy, right? This is Vr minus Vy is what? Minus Vy. This is minus Vy. Like that. Minus, yeah, in any case we are going to get V minus Vy. See, between Vr like that, Vb and Vy. Now what? That's it, right? So the resultant of these two, this is what? This is Vry. Like that, between Vb and Y, we have what? Vby. Completed, right? Okay, this is the phase angle, lagging angle, right? Phi. Then what is this angle between IR and Vry is what? We all know that this is 30 degrees, right? Between IR and Vry, 30 plus 5. Like that, between Vby and Vby and Ib. Between this Vby and Ib is what? Where is Vb? Sorry, Ib is, Ib is like this, because current lags, right? This is Ib. Okay, now it's clear. Then tell me, what is the phase angle between line voltage and line current? Like that, Vby and Ib. We know that between Vby and Vb 30 degrees, right? This is 30 degrees, but we need only the phase angle between Vby and Ib, that is this angle. This angle is what? 30 minus 5, right? That's it. 30 minus 5. We can write that point. Phase difference between, or phase angle between, IR and Vry is like that. Phase angle between Ib and Vby is, this is what? 30 plus 5, right? This is what? 30 minus 5. That's it. Now we have to write, thus the readings on wattmeter, thus the readings on wattmeter 1 is what? Which is equals to, we all know that VR by into IR cos of, which is nothing but angle between VR and IR, right? That is 30 plus 5. Completed. That's it. We have VR by, we have IR. Obviously, phase angle is what? The angle between VR by and IR. That is what? 30 plus 5. Like that, W2 is what? VBY into IB into cos of 30 minus y. Can write, and okay, the readings on bottom to W1 and W2 is what? This is VBY, this is IB cos of, what is the angle between VBY and IB? 30 minus 5. That's it, right? Then since the load is balanced, that is magnitude of IR which is equals to magnitude of IY which is equals to magnitude of IB which is equals to, these are, in case of star connection, all currents are phase currents as well as line currents, right? Therefore, what about line voltages which is equals to VBY which is equals to line voltages, right? Therefore, we can say that this which is equals to, this is line current, this is also line current, which is phase as well as line, right? In case of star, cos 30 plus 5, like that, which is equals to what? VL IL cos 30 minus 5. Clear? Then how to get the real power? The real power P is given by, simple, we have to add those two powers, that's it. It is equals to real power. Completed. Then P is equals to VL IL cos of 30 plus 5 plus VL IL cos of 30 minus 5. From this, P is equals to what? VL IL is common. This is cos 30 plus 5 plus cos 30 minus 5. That is cos 30 cos 5 minus sin 30 sin 5 plus cos 30 cos 5 plus sin 30, right? So from this, P is equals to VLIL, we can get finally the value is what? Root 3 by 2 into 2 cos 5. From this 2 gets cancelled. We are having P is equals to what? Root 3 VLIL cos 5. See, finally we are having what? Root 3 VLIL cos 5. This is active power. Okay. Next, from this we can calculate the power factor. How we can calculate the power factor? This is the active power. or real power, right? This is the active power. Next, to calculate power factor, W2 minus W1, which is equals to VL sin phi. From this, tan phi, which is equals to root 3 W2 minus W1 by plus W1. That's it. If you have any doubt, just subtract this W1 from W2. You will get VL sin phi. So from this, tan phi is equal to what? Root 3 W2 minus W1 by W2 plus W1. This is the formula to get phase. Therefore, power factor cos phi is what? Cos of phi is what? Tan inverse root 3 W2 minus W1 by W2 plus W1. This is the power factor formula. That's it. Okay. Okay, this is about real power and power factor. So from this 2 wattmeter method, we can calculate the reactive power also. Reactive power, that is Q. Means to calculate 3-phase power, just we need 2 wattmeters. That's it. That is, we know that tan phi is what? Root 3 W2 minus W1 by W plus W1. Clear? Again, from this W2 minus W1, we all know that is VL sin phi. Therefore, root 3, which is equals to what? Root 3 VL sin phi, which is equals to what? Root 3 VL sin phi is nothing but what? Reactive power only, right? Q. Then Q is equals to what? Root 3. That's it. So we have real power, reactive power. Then apparent power is equals to what? Square root of P square plus Q square. Then we all know that how we can get the reactive power. So if we consider leading power factor, obviously S equals to P minus JQ. That is, for leading power factor, Q is negative. That is, reactive power is supplied to the system. For inductive load, S is equals to P plus JQ. That is, reactive power is positive. That is, reactive power for lagging power factor load is positive. That is, the load then demands the reactive power, absorbs that reactive power, right? You can write that point here. Already we have discussed this point in the case of complex power. The reactive power for leading power factor is positive, right? That is, reactive Q is supplied to the system. Clear? Like that. the reactive power for lagging power factor is negative. Okay, sorry, for leading it is negative, right? For leading it is negative, for lagging it is positive, that is Q is absorbed, right? That is the load is right, Q is absorbed by the load. See, what is the reason here? Since S is equals to what? In this we have JQ, in this, right? Have you remember anything? So this is the concept. So for leading Q is negative, for lagging Q is positive, therefore tan phi is equals to what? Reactive power by real power. Therefore we can say, therefore it may be noted that for any leading power factor, tan phi which is equals to minus root 3 omega 2 minus omega 1, sorry, W2 minus W1 by W2 plus W1. We all know that tan phi is what? Reactive power by active power. We had a discussion in case of resonance, right? So in case of leading power factor, tan phi is what? Minus root 3 W2 minus W1 by W2 plus W1. And reactive power which is equals to minus root 3, that's it. Okay, if it is lagging reactive power, positive, root 3 W2 minus W1, that's it. We have completed the clear cut concept, VAR, right? This is what? VAR, that's it. So what is the analysis here? We have discussed that the measurement of power in three-phase load, that is we are providing the wattmeter in any two of the phases among three phases, that is which is consists of what? Current coil as well as pressure coil, that is nothing but potential coil, that is voltage coil. Current coil which is connected in series in the phases, potential coil is connected across two phases. So this is the connection diagram. Here we are providing the wattmeter between R and Y, between B and Y. Clear? So current coil measures the currents of IR and IB, like that. PC measures the voltage of VRY and VBY. That's why we can consider the phase angle between IR and VRY is nothing but 30 plus phi. By using phasor diagram, like that, between IB and VBY is nothing but 30 minus phi. So from this analysis we can conclude that the wattmeter reading is nothing but what? Power, active power only. That's why VRY, V line I line into cos of that angle, like that. For wattmeter 2, V line into I line into cos of that angle. We all know that the system is balanced system, therefore we can replace this RY and R, BY and B to line quantities. Therefore finally we have what? W1 like this, W2 like this. To get active power we have to add these two, to get reactive power we have to subtract these two, and finally we have the value of power factor. So later we have concluded some important observation, that's it. This is about measurement of power by using 2 wattmeter method.